Okay, so we left off and I said that we can represent c to the 3 over 1, or c to the third is c to the 3 over 1, and then we have 3/9. And so just as we multiplied the 3 and the 4, we're going to multiply these two fractions. And that's going to give me c to the 9/5. If you remember, the number on top is the power, so it's c to the 9th. And the denominator is our root. So we're taking the 5th root of c to the 9th. Now we can simplify this because if we were to list out 9 c's, we do have one group of 5. So you can bring a c out to the front, and then if you take 5 of those away, you would be left with the 5th root of c to the 4th. Looking at number 8, we want to take the cubed root of 6xy squared, and we are just writing this in radical, in exponential form. In this case, even though we have a y squared, we don't have the entire term squared, so we're just going to write our 6xy squared. And since we have more than one thing, we'll put it in parentheses. And then we'll raise it all to the 1/3 power. So if you're taking the 3rd root, then you can transfer that into 1/3, raising something to the 1/3 power. Now there are a lot of people who, if they were going to take the 5th root, like on our calculators, when you all use the root key, there are some people who would say, well, if I have, 8, the cubed root of 8, if that's what they're trying to simplify, then instead of having to use the math button, they would just put this in their calculator and they would do 8 to the, and you have to use parentheses, 1/3. The to the key is over on the right hand side at the top. This is an actual key. So there's some people who would rather put it in as a fraction versus having to go to math and put in the number in. Now, if we want to evaluate each expression, that means we're actually going to find an answer for these. If I have 32 to the 1/5, that means I'm taking the 5th root of 32. Like I said, there are some of you who would put this in your calculator. If you put this in your calculator, once again, if you are going to use the to the, you must put parentheses around the fraction. If you do not put parentheses around the fraction, what your calculator will do is raise it to the 1st power, because exponents trump division, and then divide the entire thing by 2, or by 5, pardon me. Working this out, what we know about 32 is it's 2 times 16. 16 is going to be 4 times 4. And then you're going to have 2 times 2. So you actually have 5 2's. So the 5th root of 32 is going to be equal to 2. If you look at 81 raised to the 1/4, means we want the 4th root of 81. Most of us should know that 81 splits into 9 times 9, and then that is 3 times 3, and another 3 times 3. That's a really bad 3, sorry. So we do have 4 3's, so our answer is going to be just 3. We look at 16 raised to the 3 halves. This actually means that we have the square root, because our root is always the denominator, of 16 cubed. Now, 16 actually can be simplified. Here, first of all, we can say we have 16 times 16 times 16. And so that is going to give us 2 16s. And then you know that this is also 4 times 4. If you wanted to split them all into 4s, 1, 2, 3, 4, 5, 6, that means we would have 1, 2, 3 groups of 4, or 4 to the third. You can say this is 4 to the third, and if you write that out, 4 to the third is going to be 16 times 4, which is 64. So our answer is actually 64. If you want to take the fifth root of negative 243 raised to the fourth, this is where you can have a negative underneath the radical. If it's the fifth root, then that means it's an odd. It means that we have something 5 different times. And here, negative 243, if I remember correctly, and I'm going to check myself because it is early in the morning and I am a bit flustered. 243 is divisible by 7. I hit time. 243 divided by 7. Nope, I'm wrong. So I need 243 divided by 3. Okay, so that gives me 81. 243 divided by 3 gives me 81. And then 81 we just said was 4 3s. So this is actually 1, 2, because it's 9 times 9, and then 3, 4. So we can write this as 3 to the 5th raised to the 4th power. Well, if you're taking the 5th root of 3 to the 5th, then you're going to have a 3, and then it's raised to the 4th power. So my answer is going to be 3 to the 4th power, only it's negative because we have an odd root. It should be negative 81. Well, the root would be the root would be a negative 3, but then when you raise it to the 4th, it becomes positive 81. Take a second and put this in your calculator. I don't have a graphing calculator at home, so hopefully I'm right. But if we do, if you put in negative 243, and then you're going to raise to the power, remember, you put in 243, you're going to use the to the key, which is over there on the right, and you have to put the 4th, 5th in parentheses. You should get 81. I hope you're seeing that. I hope that works. Let's see how many I had. Okay, so 5 more. Then I can drive my computer to school for you to see this. If you remember with our monomial rules last night, if you had x to the 2nd times x to the 5th, you are going to add your exponents to get x to the 7th. So if we have the same base, we add the exponents. So this would be 27, and if you have 1/3 plus 5/3, that is actually 6/3. If you have 6/3, that simplifies to 2. So it's 27 squared. You guys can figure that one out. Here, if we have 4/9 to the 3/2, then what we actually are doing is we're taking the square root of these two numbers and then cubing it. You can take the square root of 4, you can take the square root of 9, and then you can raise it to the 3rd power. So if you do that, if you take the square root of 4, you get 1. The square root of 9, you get, why did I say the square root of 4 was 1? The square root of 4 is 2. And the square root of 9 is 3. And then you're going to cube the whole thing. I know there are some of you who are going to be tempted, not tempted, but you're going to want to check your work in your calculator. If you did put this in your calculator, it's going to give you a crazy long decimal. You remember you can convert that back to a fraction by hitting math, and then the first thing you can choose is frac. And so you hit math, enter, enter, and you should get 8/27. A power to a power, when you're multiplying with the same base, you add the exponents. When you're raising a power to a power, then you multiply. So this is going to be q to the 3/2. And if you want to write that in radical form, what that means is we have the square root of q to the 3rd. We are going to have one pair that you can bring out. So it would be q and then the square root of q. If you factor this, you have 3 q's, and so one of them can come out to the front. We have division here, and if you remember from the rules last night, if you had x to the 7th over x to the 4th, you subtract. And so we're going to do the same thing here, only our issue is we have to have a common denominator. Our common denominator is going to be 12, and so this is going to give me 8/12, and then 12 and multiplied by 3, so 3/12. So we have the same base, which is going to give us x to the 8/12 minus 3/12, or x to the 5/12. So we have the 12th root of x to the 5th. On the last problem, first we have to multiply in our denominator. We are going to add those two because we cannot, just like we did in the last, or in a problem over here when they have the same base, you are to add the exponents. And so we need, before we can add, we have to have a common denominator. So that has to be 6/3. That is going to give me n to the 1/3 divided by n to the 4/6. And then once we get to this point, then we can subtract. Once again, to subtract, we have to have a common denominator. So it is 2 6. And then if we have n to the 2/6 minus 4/6, that's going to give us n to the negative 2/6. That's not, well, of course it's fun, because all math is fun, but we have to bring that into the denominator. So it would be 1 over n to the 2/6